Here we go. We have a question. Count the number of powerful integer. You are given three integer start, finish and limit. You are also given zero index string representing a positive integer. A positive integer x is powerful. We need to figure out the count of, we need to figure out count of powerful number. So this is the definition of powerful number. It ends with s, so we can say s is our suffix. It ends with s and each digit in x is at most limit. So we want to create a number x such that each digit in x is at most limit and no more than limit, right? And it ends with s. So this is the definition of powerful. We need to return the total number of powerful integers in the range of start to finish. A string x is a suffix. So this is just definition of suffix. We already know what a suffix is. So 25 is a suffix of this, but 512 is not a suffix, right? So let's directly jump to the example. We have given this four values start, finish and this. We need to figure out the number of values. We need to figure out the numbers that are powerful between start to finish, right? And it ends with 1 to 4. 1 to 4. So we have a range of this. So we can create 1 to 4, right? So every digit is no more than 4. We can create 1124, which is inside the limit. 2134, 3124, 4124. Then if we want to create 5124, since 5 is more than our limit, we cannot create it. So there are only 5 values. So the answer is 5. In this example, we have a range of 5 to that, and the limit is 6. So we can create 15. Can we create 15? No, we cannot create 15 because this suffix is 10, right? So can we create 10? No. We can create, our first number will be 110, then 210. Can we create 310? No, 310 is outside our finish. So there are only two values. In this, we have a range of this to this, and we want to create a value which have a suffix of this. But since our finish is less than our suffix, right, we cannot create it. So the answer in this case is 0. So let's look at the constraint value. Constraint is 10 raised to power 15, and our start and finish is 10 to the power 15. So can we apply brute force? Can we generate all the values? So our first value is 1. In our worst case, the boundary will be 1 to 10 to the power 15, and we have some string length. So let's assume our string length is 1 only. It means at the end we just want to place 1. Our suffix is 1 length. So we try to create all the values, so which will obviously give us a TLE. So we cannot go this way, but we have to optimize it. Since our range is this, can we apply under root? No. So we must solve this question in logarithmic of finish time, right? So our finish time is this, so we must solve that in that. So let's first build the approach. So we have given this test case, and we want to figure out what are all the values. Our suffix is this, our finish time is this. So we have 1 2 3 4 6 slots, and our suffix is this. So our 2 slots is already booked. We have 4 slots left. So let's say this is my prefix length. So we have only 4 slots, and we can place any value, but that value should be that digit is less than or at most 8. Then is at most 8. So we have 4 place, and our last 2 place is a suffix occupied by a suffix. Our suffix is 32. We have to place 32 in that. So in this we have these slots. So actually let me write it here. So we have 0 to 8, we have 0 to 8, we have 0 to 8, we have 0 to 8. So we can write it like this, right? But since we have given finish time, we cannot place 8 here, 8 here and then go in this way. So we must choose our value from this, right? So we have different choices. So let's analyze first. As our limit is 8, our first digit is 2. 2 is there, right? So that is our finish time. Our 2 is there. Since our range is from 0 to 2 now, and we will decide for other places after that. We have these many places 0 to 2, but if we place 2, if we place 3, if we place 4, if we place 5, so can we create suffix? No, since this is more. So let's first focus on 0 and 1. If we place 0 and 1, we can place any value from 0 to 8, 0 to 8, 0 to 8. We can place any value since this is not our boundary. Our boundary is 2, but we can place 0 and 1, and we can place from 0 to 8 any value, right? Right, that makes sense. So let's analyze this. We have 2 here. Since 2 is less than that particular digit, 2 is less than 8, it means our boundary is 2 only, and we have 3 digits in this place, 3 digits, but we will not take 3 digits, we will only consider 2 digits, which is 0 and 1. If we place 0 or 1, we can place any value, in the remaining digits. And what's the length, what's the boundary? The boundary is the limit, right? So if I place, let me write it here. If I place 0 here, I can place 0 to 8, I can place 0 to 8, I can place 0 to 8. If I place 1 here, then I can place 0 to 8, I can place 0 to 8, I can place 0 to 8. But if I will place 2, I cannot place 0 to 8. No, I cannot. So I have figured out one condition. If my digit is less than limit, right? So what I will do, I will place in the remaining cells. What are the remaining cells? First of all, since we have 2 digits, we have 2 different choices. So I will write digit multiply the remaining slots, and since this is 8 raised to power 3, we have 8 raised to power 3 slots. So what is 8? It is limit. So I can write it like this: limit raised to power 3. So how do we figure out this? I will figure out the prefix length. What is the prefix length? This is prefix length, right? And this is my remaining length. This is length is suffix length. So suffix length. This length is prefix length, and this is the total length. So finish length. So what is the prefix length? So prefix length calculated. So prefix length can be calculated as finish length minus suffix length, right? So here the limit raised to power prefix length. What is the prefix length? Prefix length minus I minus 1, right? So I can place that many values. So I can place 8 raised to power 3, right? So prefix minus I minus 1. So this is my ith place. So if this is my ith place, it means this is my ith place. I have 2 digits left. So that's how this will work. Let's continue. This is prefix length. Let's continue. If I place 2 here, what will happen? This is for 2 digits, but since I have 3 choices 0, 1 and 2, I have already considered for 2 different choices, which is 0 and 1. Now I am considering for 2. The next digit is 3. This value is 3. Again our digit, which is 3, which is less than our boundary is 8, right? Then again I have 0, 1, 2 and 3. If I place 0, I have choices this. If I place 1, since again I have choices. If I place 2, again I have choices. Right? Since my digit is 3, I can place 3 multiply. So this is 3 multiply 8 raised to power. Prefix length is 4. Ith value is 1. So 4 minus 1 is 3. 3 minus 1 is 2. So 3 multiply 8 raised to power 2. So since I have 8 and 8 choices, so which is 8 raised to power 2, and here I have 3 different choices, which is 3 multiply 8 raised to power 2. Right? Makes sense? Let's continue. I placed 3 here. Now on this digit I have different choices. I have this and these choices. Right? So 0, 1, 2, 3 and 4. If I place 0, I have again this many choices, I have again this many choices, I have again this many choices, and I will decide for 4 after that. So since my digit is 3, since my digit is 4, so I have 4 different choices. Multiply, limit is 8, prefix length is 4, 4 minus 2 minus 1, which is 1 only. So since I have 4 multiply 8 choices here, this is purely math question. Let's continue. We have 4, then we have 5 in this case. Again 5 is less than 8. Again I have different choices. If I place 5 here, I have only one choice. Oh, sorry. I have 5 different choices. Right? So I have 5 different choices, which is my digit. Multiply, limit is 8, and this is current digit 4 minus 3 minus 1, which is 0. So I have 5 different choices here. I have 5 different choices here. Right? So I have 5 different choices. I placed 5. Now I put 5 here. In our next digit, my suffix is already fixed. So that's how this will work. And we have a special case. What is the special case? Special case is, since my suffix is 32, can I place 32 here? My boundary, my finish length is 69. Since 69 is greater than 32 and 32 can be placed under 69, so our answer will increment. But what if we have given 30 and I will try to place 30, but since 30 cannot be placed, our suffix must be 30, and our boundary which is my suffix only contains 30. I cannot place 32 here, and my answer does not increment. Right? So that's why I have to take the boundary condition. I have taken 0 to 4 values. I have not considered fifth value. So here in this case, on this digit, I only considered 0 to 4 values. Then I can place 30, I can place 32. But if I pick my fifth, I have 530. Since 532 cannot be made, so that's why from 0 to 4 I can make 32. But for 532 is not possible. Right? So that's why I have to take digit, not digit plus 1. Right? I hope that makes sense. But we also have this thing from start to finish. So let me give you an idea. So we have this to this length. Right? This is my start, this is my finish. I have to figure out what are the powerful values between start to finish range. Right? Yes. What if I will do it like this. I will figure out from 1 to finish powerful digits, then I will subtract 1 to uh, start minus 1. So I will do it like this. This is my answer 1, this is my answer 2. So answer 1, let me change the color. answer 1 minus answer 2 is equal to start to finish, right? So I will do it like this. First I will calculate from 1 to finish, and then I will calculate 2. 1 to start minus 1, 1 to start minus 1. So this is my boundary, this is my total boundary, and if I subtract this boundary, I will cancel out this boundary. I have only from start to finish. So that's how this will work, right? So let's apply this on different test case. So I have this. So let's calculate it for this value. I will create a tree for this. Since I have 1 2, so I have how many slots? 1 2 3 4 5 6 7 8. I have 5 slots, 8 slots, 8 slots, and my last digit should be 2 5 6 and 8. This is my suffix. I have to create value for this. This is my prefix length. What is the prefix length? Prefix length is finish length minus suffix length. So this will this is my prefix length. So let me create 4 slots here, and all the remaining slots is booked for suffix. On my 0th bit, on my 0th value, I have 2 choices. So I have a solve function. This is my index. I have how many choices? This is 1. My finish first digit is 1, and I have limit till 9. So how many choices I have? I have 0. I have 1 choice, right? Since this digit is 1, I can only place from 0 to 1. So I have already told you, if my digit is less than limit, I can only place that many digits that is present on that value. And for simplicity, I will create an example for this. Yes, right? So since I have 1 here, I have 2 choices. Either I will place 1, either I will place 0, or I will place 1, right? So if I place 0, so if I place 0 here, how many choices I have? I have 0 to 8, I have 0 to 8, I have 0 to 8 choices, right? So if I place 0, so this will open up for all the values, right? I have placed on this value, I have placed 0. So here I have 0 to 8, I have 0 to 8, I have 0 to 8 choices. I have 8 different choices on every single value. So I have 0, 1, 2, 3, 4, 5, 6, 7 and 8. I have that many choices, right? Again, for solve of 2, I have again from 0 to 8 choices. So let me clear out. On index 1, I have 0 to 8 choices. On solve of 2, again I have 0 to 8 choices. For solve of 2, I have again 0 to 8 choices. For solve of 3, same, I have 0 to 8 choices, right? That makes sense. So let me write it here. If my current digit is less than limit, then I can place digit values on that particular index multiply limit, so which is limit on the remaining slots. What is the remaining slots? Remaining slots is prefix length minus 1 minus I slots, right? Else I will write it, if I place 1 on this cell, what are the different choices I have? I am onto this index. So I have either I can place 0, I can place 1, or I can place 2. If I place 0 on this particular value, again I have 0 to 8 choices, 0 to 8 choices, 0 to 8 choices, 0 to 8 choices, right? So I have 2 here. For 2 I can place 8 raised to power 2, right? So which is 2, 8 and 8, right? Makes sense. So I have this, but if I placed 2 in this, I have to analyze for other slots. I have 9 here. This is interesting, right? I have 9 here, but since my limit is only 8, I cannot place 0 to 9. No, I cannot place. My limit is only 8. So I can only place till 8. Till 8. And on the other bits, I can only place till 8. So in our else block, what I have? If my digit here, if my digit is either greater than my limit or equal to my limit, I can only place till limit value, no more than that, right? Makes sense. My limit is only 8. I can place 8 bits, so I will place 8 bits here, I will place 8 bits here. So I will do it like this. So apply limit limit raised to power prefix length, which is prefix length is 4, prefix length minus I. So if I do it like this, so prefix length is 4, 4, and my I, which is my current position, 0, 1, 2, only 2. So I can place 2, 8 choices on this cell, 8 choices on this cell. So that makes sense, right? So my answer will increment on this value, and my answer is increment on this value. Since I have already placed 8 and 8 bits, I will just return my answer from this state. I will not calculate it further. I will just put 8 and 8, and I will just do my calculation, stop the calculation, just return the result, right? Makes sense? Yes. So that's all for this test case. What if we have a different test case? So let me write it like this. I have 7 here, right? So again I have 0 to 7 choices, 0 to 7 0 to 1 2 3 4 5 6 and 7. So if I place 6, so this is 7 choices, I have 7 choices, multiply, I can place 8 here, 8 raised to power 1, only one slot left for 8. But if I place 7 on this cell, on this slot, if I place 7, and I will jump on to next cell, again I have 4 different choices, 0 1 2 3 and 4. I have these 4 different choices, so I will place 4 here. But for the fourth cell, if I placed 4 here, so I have these 4 cells left. Can we place 4 4? So if I place 1 2 7 and 4, 1 2 7 and 4, can I make my suffix, which is suffix is 2 5 6 and 8? Can we make this particular, which is my last powerful digit, can we make this? So to calculate that, what I will do, I will just find out the last 4 digits, which is the suffix length. Suffix length is 4, so I will just take 4 values inside, 4 value from it, and I will just check if my finish is more, it means I can create the last powerful value. If my finish is not more, if my finish is like this, if my finish is 1 1 2 3, so it means my suffix, my finish time is less, my last powerful digit cannot be made. If I place 1 2 7 4 and I try to make this value, I cannot make, right? I hope that makes sense. So my problem breaks down into 2 or 3 steps. The first step is to first calculate uh, from my objective is to calculate from start to finish time. I will calculate from 1 to finish time, then I will subtract 1 1 to start minus 1 time, right. I will figure out this, I will subtract this. To calculate this I have just a simple recursive function. So this is very simple question. Now my problem breaks down into this recursive function. I just calculate this. So let me write the code. So I have finish time and the start time. So what I will do, I will just create a finish function which is finish. Create a solo function, recursive function. I have finish here, and I have my s here, which is my suffix. I have my limit here, and I will calculate finish minus. I have to figure out start minus 1 s and limit, right. I have this solve function. This is my finish on array step, right. So I have first calculate till finish, and I will subtract, this is my finish point for this recursive function, right. And then I have, this is suffix, this is not suffix, this yeah, this is suffix, yes, this is suffix. And I also have limit, right. Yes, I have these many things. And instead of this, what I will do, I will get finish as a string. I will just get as a string, right. So I will first to figure out the prefix length, and before that let me calculate the finish length. This is finish length, and suffix length, and then we have prefix length, which is finish minus s, right. So for this example we have 4 slots, so 4 minus 3, which is only 1 slot, so I have 1 slot only in this case. So just write a for loop, 4 slots till prefix length. Calculate the digit, find the digit that is present on finish character, finish ith character, right. So for this example I will get 6. So I need to figure out if so let me commit here, yes. So this is yeah. So I have this on this cell, I will first get this 1. So I have to figure out if my digit is less than limit. If my digit is less than limit, and I have that many choices, right. So for simplicity, let me write 4 5 7 and 9 and 7, right. 9 and 7. So this will handle all the cases, if case and else case. So I have 4 here. 4 is less than limit. I can place 0 1 2 3 and 4, right. So obviously I can place 4 digits, and for fourth I will calculate it further, but I can place 4 digits, then 8 8 8, it means 8 raised to power 3, right. 4 multiply 8 raised to power 3. What is 4? 4 is my current digit. I can only place 4 if my current digit is less than limit. So if my digit is less than limit, right. So I need to create answer. So what I will do, I will multiply digit, multiply, first I have to convert into long, limit raised to power that many slots. So that many slots, which is prefix length minus I minus 1, prefix I minus I, prefix length minus I minus 1 slots, right? And this will continue. Else, so obviously I have figured out for 0 I can place, so I have figured out I can place 4 multiply 888, but if I place 4 on this particular cell, I have to go further and calculate for the boundary condition. So for 8, again I have 5, it means I have 5 choices here, and I can place 8 and 8. Yes, this will do the work. So if I put the boundary thing, I will place 4. I have 9 here, it means I can place limit only, I can place limit and limit. So this will come inside the else block, and I will try to put 8 and 8, right? So in the else block I have math power convert into long, limit raised to power prefix length minus I slots. So in this cell I have 9, but I can only place 8 and 8. Since this is 8 raised to power 2, how do we calculate? This is prefix length, which is 4, minus my current I digit. Current I, my I is on 2, right? So prefix length minus I, if I do like this, which is 4 minus 2, which is 2. So this is 8 raised to power 2, which is limit raised to power 2. So that's what I have written here, limit raised to power prefix length minus I. So prefix length minus I, and just return the answer in this case. So this will handle this case. What if we have different case? We have this case. So I have 7 choices obviously, which is 7 multiply 8. This will do the work. But if we place 7, which is the boundary thing, I have this limit, I can place 7 here, this will do the work. But if I place 7, which is the boundary thing, I need to figure out if I can place the last set, the last digit, the last suffix. So I have to figure out this. So let me get the suffix length. So let me get this 4, the 4 values from this. How do we calculate like this? So 0, 1, 2, 3 and 4. 4, right? Suffix length is also 4. I will find finish substring from 4 onwards. So this will return me this. So if okay, finish dot substring suffix length, if this is yes, so this will give me the last 4 digits, and I will compare it to suffix. So I am comparing 1 1 2. So here 1 1 2 3 is compare with 2 5 6 8. If this value is greater than or equal to 0, it means if this value is equal to this value, or this value is greater than this value, this will give me 0 or greater than 0. So if this is true, it means I have the boundary thing, boundary power also, and that's all, right? So this will do the work, but so this will do the job, but let's figure out what we are doing. We are first calculating this finish, then we are subtracting start minus 1. So we are finding till finish then we are subtracting start minus 1. Since my start is only 32, and my suffix is more. So does that make sense? We only need to calculate 1 1 till 1 till finish time. So here 32 till my finish time is already included. So do we even need to subtract this, right? So do we even need to subtract this? My suffix should be more, my suffix length is more. So this is start time does not make sense, right? So if my start time is less, if my start length is less than this length, it means I cannot find start minus 1 from 1 till start minus 1. If my suffix length is already more, it means I cannot find any substring. I will just directly return 0, right? If my suffix is more, so for this, if I am passing this start minus 1, my finish will get some length. So if my finish length is less than my suffix length, I cannot create any value, right? And I observed this thing, my start length, and that's all. Yeah, this is less than, yes. So let me run this and I hope this will work. So we have an issue here. So first of all, this symbol should be greater than, it means my finish time is more, right? If my finish time is more, so in this case I can only make the boundary which is 4577 and 2568. I cannot make this, but since my this last 4 digit is less, but if my last 4 digit is more or equal to or more, then only I can make the last powerful value, right? And we missed one more thing, which is this thing. So what we are doing in this case, this will obviously not go here, since fn, which is finish length, is 4 and suffix length is 4. So 4 minus 4 will cancel out, we are not going here. Finish length, since my suffix length is 4 and the fourth value is not accessible, so we are not going there. But since this boundary we can create one powerful value, we can create this value. So if both length is same, we again try to figure out if my finish time is more. If both length is same, so this is just a special case, both length is same, just to figure out if my finish is more than suffix. If this is the case, we have one powerful value. So there is some issue in this code. Let's figure out. We have this condition, we have this case, and in this case we have that many digits, 1 2 3 4 5 6 7 8 9 10. So we have 10 slots, 2 3 4 5 6 7 8 9 10, and 4 slots is already booked, 2 5 6 and 8. We have that many slots. My digit is 4, which is less than limit. I can place 4 values, 0 1 2 3 4. So I will place these 4 digits without thinking about the next case. So I can place 4 values here, and in our in other blocks I can place 8 8 8 8 8. So 8 is placed by 5, 8 is placed 5 times, right? Since we have 5 remaining blocks, so my limit is 8, but we can place 0 1 2 3 4 5 6 7 8. So we have these many choices, we have 9 choices. So this will 4, 9, 9, 9, 9 and 9. So this is 4 multiplied 9 raised to power 5. So first thing is this condition is not limit, this is limit plus 1. So this is first mistake. Then this will do for 0 to 3, but if I place the boundary, my boundary is 4. If I place the boundary, the next condition is 8. The next value is 8. 1, 2, 3, 4, 5, 6, 7 and 8. Again, we have 8 choices here. I can place 8 choices. Then 9, 9, 9 and 9. Yes, for the boundary thing, I will calculate it further. So I have again, if my digit is equal to limit, I will place digit value. It means 8 values multiply 9 raised to power something. Right? Makes sense. So this will do the job, and I think this will work. Let's run this. Yes, working fine. Let me submit this. And yeah, we have a mistake here. We are missing something. So my for loop is working fine. Let's calculate it for this value. Right? So we have this thing, and in this what we are doing, we are finding finish substring sn. So what is sn? Sn is 4, which is sn is 4, and I will go to fourth value 0, 1, 2, 3 and 4. I will come to here. But is it the case? No. I have to pick the last 4 values. So my sn thing will not work. I have to figure out the last 4 values. What is this length? 9. What is this length? 4. So how do we calculate the last 4 values? I will get 5. So 0, 1, 2, 3, 4, 5 and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have to reach this index. So my fn is 10 and my sn is 4. So 10 minus 4, which will give me 6, and I will then reach this value. So I have to just do fn minus sn. So this is the mistake, and yes, now it's working fine. So let's discuss about the time and space complexity. In this function we have this solve, and this solve we have this for loop. So what is this for loop? We have prefix length. It depends on finish length minus suffix length. So let's suppose my suffix length is 1 and my finish length is what is the finish length? In the worst case, the finish length is 16, right? So 16 minus 1, which is my prefix length. In the worst case, this will happen, and I have that many choices. I have digit many choices. So digit is depends on what is the digit on any given place. We have 0 to 10 digits, right? So we can place 9, and so since this will make a tree, so on tree we have different choices, and our stopping point, our base case will be when we reach the finish length. So in total, the tree length on every step we are multiplying with 10. We are just multiplying with 10, and we will reach the base case. So the time complexity overall will be logarithmic of finish. And for space, are we utilizing any space? Seems like we are not utilizing any space, but since finish, so finish is a long and we are converting into a string, so this will create a space. And we have this substring, since we are utilizing a space, so this will also be logarithmic of finish time. So that's all, and let's wrap up this video. Thank you all for watching.